Hello viewers, the question is 4-point charges QA equals to 2 microcoulomb, QB equals to minus 5 microcoulomb, QC equals to 2 microcoulomb and QD equals to minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? So this particular problem is based on the application of Coulomb's law. There is a square and the corners of square there are located four different charges. The value of charges is given, the side length of the square is given, and there is a charge at the center of the square which is at the crossing or the intersection of the diagonals. This charge is of value 1 microcoulomb. So we have to find out the force on this 1 microcoulomb charge due to all the other charges. So to solve this particular problem, we can solve this problem analytically as well as with the help of the calculation also. First, I am doing this solution or the problem, solution of the problem analytically. For example, if you want to calculate the force on the charge 1 microcoulomb due to the charge placed at the corner A. So the direction of the force is away from this charge. For example, let us call this force as FOA, which is the force on the charge placed at O due to the charge placed on A. It has certain magnitude. The distance, for example, is R here. So the magnitude depends upon this length R as well as these two charges. Similarly, the force on the 1 microcoulomb charge due to the charge placed at the point C, which is of value 2 microcoulomb, is opposite to this particular force FOA. So this, let us call this as FOC. This force is FOC. The direction is exactly opposite to the direction of FOA and the magnitude is same. The magnitude is same because the charges involved are same. The pair of charges involved are having the same magnitude, for example 1 microcoulomb and 2 microcoulomb, as well as the distance is also same, which is, let us suppose, is R. So we can say that FOC and FOA magnitude is same. So if there are two forces acting at a point and they are opposite exactly 180 degree, making an angle of 180 degree, and magnitude wise they are equal, then they cancel each other. So these two forces cancel each other. Similarly, the force on 1 microcoulomb charge due to the charge placed at point B is in this direction, that is from O to D. Let me correct this. This is toward point B because now one charge is positive and one is negative. So it means that FOB is towards the charge at B because they are opposite nature charge. So FOB, which is the force on the charge placed at O due to the charge placed at B, is towards B, and its magnitude depends upon the magnitude of the charges, that is minus 5 as well as 1 microcoulomb, and the distance here is R. Similarly, the force on 1 microcoulomb charge due to the charge placed at D is towards the charge D, charge placed at D. Let us call this force as FOD. So FOD is toward the charge placed at point D, and the magnitude of FOD and FOB, they are same because the charges, pair of charges involved are same magnitude, as well as the distance between O and D is also R, for example. So in this way FOB and FOD cancels with each other. So in this way we can say that the overall net force is 0. So F net is equal to 0. So this problem can be solved by using the analysis alone. Suppose we want to use the calculation to solve this problem. So by using the calculations, for example, the net force is given by FOC plus FOB plus FOD plus FOA. Now writing these force expressions by using the Coulomb's law, FOC, it is K, where K is 1 upon 4 pi epsilon naught. So K times Q1, Q1 here is 2 microcoulomb and Q2 here is 1 microcoulombs, and R here is, we can calculate the R also. For example, the side length of the square is 10 centimeter, then the diagonal length AC is equal to 10 root 2, and from this value we can calculate the value of OA. OA is half of this AC, So it means that 10 root 2 divided by 2, which is equal to 10 upon root 2. So in this way we have calculated OA. In a similar manner, OB, OC and OD, they are also equal to 10 upon root 2. So 10 upon root 2, 10 upon root 2 is the value of R and its square, and the direction is along, direction is from O to A, the direction is from O to A. Then FOB, FOB is K times the another charge, which is now here the charges involved are 1 microcoulomb charge and second one is 5 microcoulomb charge, and upon 10 upon root 2 whole square, and the direction is from O to B, direction is from O to B, and in the first case FOC, direction is from O to A. Now the third force is FOD. So FOD is equal to K times the first charge, which is minus 5 microcoulomb. So here we write only the plus sign because we are considering the direction, so that's why there is no need to write the negative sign. So 5 microcoulomb multiplied by 1 microcoulomb upon the distance between them, between O and D, it is 10 upon root 2 and its square, and the direction is from O to D, O to D. And the fourth force is FOA. FOA is along the direction OC and its magnitude is K times the first charge, which is 1 microcoulomb, the second charge, which is 2 microcoulomb, upon 10 upon root 2 whole square, and the direction is from O to A, direction is from O to A. So in this way we have calculated the net force. If you can see that the fourth one is FOA, the direction is from O to C. Let me correct this, this is O to C. So in this way, the first term, it cancels with the FOA, cancels with FOC. So FOC is this term. So this cancels, these two terms cancels with each other because the direction are opposite. Similarly, this particular term, that is O to B direction, cancels with O to D direction force because the magnitude are same, the direction is opposite. So in this way the net force is equal to 0. So by using the calculation also we can solve this particular problem. तो यहाँ पे एक प्रॉब्लम दी गई है जिसमें कि एक स्क्वायर के चारों कॉर्नर्स पे डिफरेंट चार्जेस प्लेस किए गए हैं, चार्जेस के मैग्नीट्यूड दिए गए हैं, सेंटर पे इस पर्टिकुलर स्क्वायर के सेंटर पे एक चार्ज रखा गया 1 माइक्रोकूलम का, इस पे नेट फोर्स हमें कैलकुलेट करना है। तो ये पर्टिकुलर प्रॉब्लम कूलम्स लॉ और प्रिंसिपल ऑफ सुपरपोजिशन पे बेस्ड है। प्रिंसिपल ऑफ सुपरपोजिशन मीन्स कि जो नेट फोर्स होगा वो डिफरेंट इंडिविजुअल फोर्सेस का सम होगा। इंडिविजुअल फोर्सेस जो कैलकुलेट होंगे वो डिफरेंट 4 पेयर ऑफ चार्जेस की हेल्प से कैलकुलेट होंगे। तो यहाँ पे जो नेट फोर्स होगा वो बराबर होगा FOA प्लस FOB प्लस FOC प्लस FOD। तो ये डिफरेंट फोर्सेस जो हमने कैलकुलेट किए हैं, इसके लिए हमने कूलम्स लॉ यूज़ किया है, विच इज़ K(Q1 Q2 अपॉन R स्क्वायर। यहाँ पे R होगी डिस्टेंस बिटवीन O एंड A, या हम कहें O एंड B, या हम कहें O एंड C, या हम कहें O एंड D। और यहाँ पे कैलकुलेशन करके हम पहले डायगनल निकाल लेंगे। डायगनल इसका और 10√2 का हाफ करेंगे हम, तो हमें O से यानी सेंटर से लेके डिफरेंट कॉर्नर्स की दूरी पता लग जाएगी, विच इज़ 10/√2। और इसको जो है हम यहाँ वैल्यूज पुट करके इसको सॉल्व कर लेते हैं। हम देखते हैं कि फोर्सेस जो है वो एक दूसरे को कैंसिल कर रहे हैं, अपोजिट फोर्सेस एक दूसरे को कैंसिल कर रहे हैं क्योंकि मैग्नीट्यूड वाइज वो सेम है और डायरेक्शन उनकी एग्जैक्टली अपोजिट है। सो इस तरह से हम देखते हैं कि ओवरऑल नेट फोर्स जो होगा वो क्या होगा, 0 होगा। सो दिस इज द एक्सप्लेनेशन ऑफ दिस प्रॉब्लम। होप यू अंडरस्टैंड इट। थैंक यू।